So, now let us see how to relate the surface tension and the free energy of a liquid surface. So, let us imagine a wire frame that is rectangular in shape, and we have a here wire. So, now you see here we dip this into a soap solution. So, we have dipped it into a soap solution. So, what will happen, unless we hold it by some external force, this wire will be stretched by this liquid. So, I have to apply some force F. So, I have to apply that force F, and now suppose I move this and bring this to this position so that it moves by dx distance, and suppose L is the length of this wire. So, L is not length from here to here, but from here to here length. So, consider a soap film, consider a soap film formed on the rectangular wire frame, as shown in figure. Now, let F be the force, that is external force that is applied slowly to stretch the film by a distance dx. Let dw be the work done in doing so. So, now let us see the cross section, this cross section. So, you see the circular cross section of the wire I am showing. This is the cross section of wire. Now, what happens? The liquid film is like this. So, this is the liquid film. This film has a thickness very small, and you can see the liquid inside this. So, there are two surfaces, one is the upper surface and this is the lower surface, upper surface. So, any film like this upper surface will have two surfaces, upper surface and lower surface. So, you see here there is a force. So, now you see here this is L. So, there is a force and you have to apply that external force equal to that force. So, now let us see what is the work done. So, this is the work done by external force, that is F into dx. What is a force? That F must be equal to the surface tension force, and this is F into dx. So, this surface tension force is S acting that direction, surface tension F into L. So, here F into S surface tension. Now, you see there are two surfaces. So, this side SL force and this side also SL force is there. So, I have 2 SL force is equal to F dx, that I will denote by work done. Now, work done is equal to this. Now, let us see that when we stretch a liquid surface, then it becomes cool, thereby absorbing heat from the surroundings. let dq amount of heat is absorbed in this process. So, let the amount of heat absorbed is dq in this process, and since there is a change in the surface area of the film, so there is also a change in its potential energy or surface energy. Let E represents the surface energy of the liquid. Let the change in the surface energy E represent the surface energy, let per unit area be this. So, of the liquid, let the change in the surface energy be dE. So, from laws of thermodynamics, law of thermodynamics, what work I have done, the change in the free energy of this is equal to the work done on us, but the heat taken out by this. So, here I am giving some work done, and that goes into the energy of the surface, and it absorbs delta q amount of energy from this, and so this is the surface energy, that is the surface energy, that is the potential energy of the film. So, now you see here we have a equation which tells dE is equal to dq plus dw. So, let deduct dq. So, what is this part, and let us start what is this part. So, this part dE is change in the surface energy, that is the potential energy of the film. So, when you stretch it, the area will change, and so new surface will be created. So, there will be a change in the surface energy. This is called the thermal part of the surface energy. So, you see here the surface energy or the change in surface energy has two attributes. One, the thermal part of the, and this is called the mechanical part of the surface energy, and it is called free energy. So, or the mechanical part of the surface energy. So, the work done dW, and I will call this dW as suppose d eta, thus dW. So, dW is equal to F into dx, F is equal to 2s into L dx, and you see the total area is upper and lower, that is L dx and again L dx, means 2 L dx is again dA. So, we have S is equal to dW by dA. So, we now write this as thus surface tension is equal to the free energy the free energy or mechanical part of the surface energy per unit area. So, S is the mechanical part of the surface energy, which is actually called free energy per unit area. So, the free energy per unit area of a surface is equal to the surface tension of the liquid.